Hello, I'm Jeremy Schulman, Head of Customer Enablement at Apstra. Welcome to our webinar titled Intent-Based Networking, Bridge the DevOps Network Divide. Today you're going to learn about Apstra and our product called AOS, Ansible for networking, and see demonstrations of using these products together. Today our two technical speakers are Damien Garros, who's our Customer Enablement Engineer from Apstra, and Andrius Benokraitis, the Principal Product Manager for Ansible at Red Hat. For our agenda, Damien will start off by introducing Apstra and AOS. Apstra was founded to enable the self-operating network, which is a network that configures itself, fixes itself, and defends itself. To achieve this vision, we have assembled a unique team that has pioneered a new market called intent-based networking. Gartner recently released a research paper describing intent-based networking as, quote, networking software that helps to plan, design, implement, operate networks that can improve network availability and agility, end quote. So after Damien, Andrius will present Ansible. Ansible is, of course, a keenly popular DevOps product, and Andrius will cover their approach to automating network workflows. And then Damien will put it all together by demonstrating how you can use Ansible to automate AOS and network workflows using the new AOS modules that are part of the latest Ansible 2.3 release. And then finally, we're going to wrap up with some Q&A. So please, if you do have questions, enter them into the area under the presenter's screen. So with that, Damien, please start us off.
Thanks, Jeremy. Hello, everyone. So before going into and talking about what AOS is doing, let me quickly introduce Apstra for those that are not familiar. So we are a startup, and we have a very strong founding team. Our three main founders are Mentor Karam, Sasha Radkovic, and David Sheraton. They all are veterans of the networking industry with a strong backgrounds around business developments, technical excellence, and funding startup and adapting to markets. So Mentor is our CEO. He's coming from a background with Stanford and a PhD at Stanford. He worked at Arista and Big Switch. Sasha Radkovic is our CTO, leading all the technical aspect, and he's coming from Juniper. And David Sheraton is our chief scientist and our main investor, and he was one of the founders of Arista, and he was also involved in Google and VMware. The team behind those three founders is also very strong, and our talent and expertise are really around first we-networking and distributed system, and solving those very complex problems at scales. But also, we have a lot of focus, of course, in automations and all the abstractions that needs to be constructed on those automation tools in order to properly understand and automate the networks. And also have a lot of people that have been in different startups and with all the agility and the needs to adapt to the market size and the shift that requires. Jeremy mentioned that we are the product AOS for the Apstra operating system that we're building is really playing in a new market named the intent-based networking system, as Gartner has defined it. And I think a good way to define that is really what Sasha, our CTO, has put together is we are really doing both the configurations and the validations, the troubleshooting, and the operation of the networks all at the same time. And AOS will configure, then it will continuously validate the operational state of your network. And having those three functions plus more bind together is really build a new type of product and that's what we're going to explain today, bring a lot of value. So if we look at AOS, the product will really help you through all the life cycles of your networks, and it will let you first start to design, and then you will be able to use our product to build, deploy, and operate or monitor your networks on these productions. And the way we see it is actually the build, deploys, and operate phase is actually a loop that you will continuously go through every time you have to do a change. A change in your network is nothing but a new build that will require a new deployment, and that will set some new expectations on how the network is supposed to look like. And AOS really comes with the very tight integrations on those steps with the notions of continuous validations and we'll show you how this part works. So let's look at those three phases and let me explain really how AOS is different from the traditional approach. So first, for the design phase, the idea is that instead of doing handcrafting design on whiteboards or on Visio, you will actually use the tool to design your networks. And we have these notions of reference design or network design, and it means that AOS has the ability, knows about what is, for example, if I take a design as an example, a spine and leaf for a data center, AOS has what we name a cartridge internally. And in this cartridge, we have all the knowledge of how Must looks like an IP fabric, and it will guide you in the design and how you implement that. You will have the ability to provide your inputs and define your own expectations on how the network must look like how much bandwidth do I need to provide, what type of servers do I need to connect, what speed of my interfaces, what type of physical device do I want. But the system will ultimately help you to design the cabling plans and all the configuration, generate all the different artifacts like the IP addresses and the variable, the ASN that you need, because it has this deep knowledge of what is the design. We do talk a lot about the spine and leaf for the data center, but the platform itself is actually can incorporate any type of design. It's just a matter of creating those cartridge that will help you build any type of design. Once you have designed your networks, then you will be able to deploy that. And I actually forgot to mention that the design phase, in our view, is really vendor agnostic. When you talk design, you talk how many ports, how much speeds, what functions does my network need to provide? Does it need to provide layer 1 connectivity, layer 2 connectivity, layer 3 connectivity? But at this stage, we don't really have to worry about specific network vendor. And now when you want to build the network, when you really want to take a design and implement that, you will have to provide more options like what is my real vendors, what are the templates for the configurations that I need to use, and the AOS will help you with that. So first, along with the reference design inside this cartridge that I was talking about, we do provide those templates that you can customize, but they do come with the product. And also, the AOS will help you to provision all those artifacts. Instead of, you don't have to manually provision every single IP addresses for all the link, for example, in IP fabric. You will just say, here's this big network subnet, and please assign /31 subnet to every link out of this /16 subnet, and AOS will help you to allocate all those resources and manage them. Now, at this point, you're being able to define your networks, generate all the artifacts, generate all the configurations, and deploy the configurations. But based on my experience, provisioning is really the easy part. And when I say easy, I really understand that people that are new to automation usually start from provisioning and already see that as a big achievement when we are able to automate. And Ansible has been a very successful tool, and those are tools to help people automate the provisioning. But we believe at Apstra that the big part, the hard part, is actually coming next when it's about operating a networks in a really automated way. We did a survey last year named the DevOps survey to understand how people are using automations to automate their networks, and it was really clear that most of the people that are actually touch network automations today have been focusing on provisioning, and very few have passed the second step, which is really troubleshooting and operating. And that's where we think AOS is bringing a lot of value, because operating is not easy, and especially because the idea is why is it not easy to operate the networks in an automated way? And The way we see that is today, when you create and you design and you automate your networks, you will usually create your Jinja templates and define your inputs, and you will automate all that so that you will build the right configurations for every device in your networks. But the real knowledge of how the network must look like actually live inside your head. And there is no easy way today to really translate that in the business logic. Meaning, on the other side, once you have deployed the configurations and you need to monitor and you need to troubleshoot your networks, if you need to reverse engineer all the states of the networks and the configurations, it's going to be very hard to understand what is the network is supposed to be. And also, in this approach where we define all the devices one by one, it is really that every device will be seen as an independent component, where the truth is the network is really a distributed system. Every time a device, like if the spine, for example, if one spine goes into maintenance mode, then all its peers should not expect their BGP sessions toward this spine to be up. So you really have to update all the other members, and that's really what AOS provide with these notions of intent and expectations. I will go into more details on that. So when you start thinking about that, our approach to operation is very different than what we are doing today, because today the way people operate and troubleshoot is usually when they suspect that something goes wrong, they will start to collect information, go in CLI and check, and based on their understanding of how the network looks like, they will start to investigate to find what's going wrong. In our case, everything is integrated because we do know how the network must look like, because we have all the intent and the information about how you want it to be. And based on that, the system will generate two informations. One, which is it will generate the configuration, but it will also generate how we expect it to be from all the states. And based on that, we will be able to compare. So first, we do have an engine that will continuously, every few seconds, collect all the states that are important in the networks, like the states of the LLDP, the states of the BGP session, all of those information, and we will continuously compare the running states of the network with the expected states of the network, and based on that, we will trigger an anomaly. So how do we do that? And we really see AOS as a distributed operating system for the intent-based networking system. And if we look, we have really three major components. So first, we have the platform. And as I mentioned earlier, the platform is really vendor agnostic, design agnostic. It is not specific to any design and not to any vendor. I'll go in more details about that. And then you have the cartridge, or the network, all the information that are specific to a network design, to a specific network architectures that you want to implement. It will come with the understanding of what is, for example, the spine and leaf. It will come with the templates. It will come with all those specific information. And then we'll have the device agents that will help us make the translation to the vendor-specific language and the vendor-specific APIs, and all the understanding of how we will deploy configuration, how we will collect information lives in the device agent. To put all the pieces together, as I mentioned, if we look from the top to the bottom here, when we come with a new cartridge and we design it and we build it, and then what's happening is based on both what the cartridge knows about the networks and based on what the operators are as defined, that we name as the intent, the system will be able to build your networks and create all the artifacts. And based on that, it will define all the services that needs to run in your networks, like BGP and the states of the LLDP and the routing tables. And it will generate a set of expectations, as I mentioned earlier. And those expectations then will be used as the base to continuously compare with the real status of the networks and the real status of your live states. And as soon as something diverges, then an anomaly will be generated. And those expectations are continuously updated based on what you're provisioning. As I mentioned earlier, if we take the example of if I want to take one of my spine out of service, for example, because I want to upgrade it, so I will say, okay, I want to put it in maintenance mode, and then I will drain out the traffic, and at some point the device will reboot. Then once we take the device out of service, AOS will automatically update the expectation on all the peers of this device, and actually even beyond the peers, so that nobody will expect anymore to learn the loopback of this device. Nobody will expect anymore to have any BGP session up to this device or have interfaces up toward this device, so that make sure that during this process, as the device actually reboot and upgrade itself, no false anomaly will be generated. It is often one of the parts that is very complicated to automate is that to make sure that we reflect and we collect the information of all the devices to understand how the networks as an entity, as a system is behaving. Then we have the platform. As I mentioned, the platform is vendor agnostic, and it has all the construct about collecting information, building the template, generating those expectations. It has components about all the real-time telemetry, some time series databases. There's some ability to stream all the information out. Everything is API driven, and we do have a UI for our users, but the UI is entirely based on our own APIs. So you have the ability to use either the UIs or the APIs to drive the platform. And the last part is the device agent, the part that really has all the knowledge of the specific networks vendor you're talking to. And we support a wide variety of vendors, the traditional ones like Arista, Cisco, and Junipers, but also more the white box players like Cumulus, Dell, SnapRoute, as well as the pure Linux system like Red Hat, Ubuntu, or others. We do also support the ability to run layer 3 on the server itself, and we will be able to manage layer 3 daemons like Quagga, for example, running on Linux if you want to have active BGP sessions down to the server. Our preferred solution is actually to have an agent running directly on the device that we manage, and it will be, if we can, we will run that on Arista, Cisco, or Cumulus. But if the device does not support to install an agent, we'll also be able to run in agentless mode. With that, I hope you have now a good understanding of what AOS is and how it can help you to automate the whole life cycle of your data center. And I'm going to hand over to Andrius to give you a good understanding of what is Ansible. And I'll come back to present how both are now working together to help you really automate all steps of your network.
Great. Thanks so much, Damien. I really appreciate that. And thank you all very much for joining. I'm going to give you a quick overview of Ansible, since this is going to be the foundations for AOS as well. So we'll just jump right in. So I'm going to back up a little bit and say, well, why are people using Ansible in the network? This is a quote from SDX. Some of you all have been on SDX Central. It's a pretty common networking website. And most people ask, why do you use this stuff? Why do you use it for networking environments? The simple answer is it's truly the final frontier in next generation data centers. Operationalizing and automating networks really isn't as pervasive as automating compute and storage today. We all know that system administrators have been automating servers, virtual machines, and containers for years, but the automation of networking, switches, routers, load balancers, firewalls, etc., are still kind of viewed as custom niche or DIY deployments. This quote definitely validates that network automation still has plenty of growth opportunity in the IT space, and we at Ansible and Apstra are trying to change that. Long are the days of committing changes by hand, crossing your fingers, and keeping a close eye on your cell phone, right? So full integration testing, what's done in the server world can now be done for the network. When testing is validated, it provides the network operators the confidence to know that changes will succeed in production. And if they don't, they have the ability to roll back to the last known good and start again. Although there are different ways to operationalize your network infrastructure, let's take a look at some benefits of using Ansible and automating in general. But for Ansible, it's truly simple. Everyone can learn it. You can almost use it immediately. You can automate the tasks they do today. Since most network engineers wouldn't consider coding or application development a true core competence, the framework that Ansible provides makes it easy for network engineers to convert how policies, what they're familiar with, map to tasks, which get then automated and executed in order. The way Ansible playbooks are written and run can be implemented the same way a network device is installed, provisioned, configured, and maintained in a production environment, only much faster. What makes Ansible powerful is it's been designed and built for flexibility for many use cases. The underlying architecture and automation engine enables for development of modules, which for the purposes here, Apstra has created modules, Ansible modules, to enable AOS, can extend functionality without boundaries. The roots of Ansible started in the server world, but are now being quickly adapted for the network world because of the ability to operationalize automation in existing networking CLIs, as well as create bridges to DevOps in next generation networks. As Damien's going to kind of demonstrate later, you have the ability to create. They created these modules and curated them and maintained them. You have the ability to create your own modules and integrate with the AOS system as well. So, and the last thing here is that Ansible is agentless. So we can connect to the AOS platform without any agents or anything there. So we're connecting via accepted transport mechanisms like SSH. You don't have to worry about having to worry about an agent on your device going to the AOS platform. Damien mentioned a little bit about ensuring your life cycle is proper, but I want to focus on three high-level benefits that are instrumental in the success of network operations as part of your full-blown lifecycle management platform. The first is that Ansible is the documentation for your networking hardware. It's truly just a giant configuration that lives on the device. It can be fetched, organized, utilized as a backup, et cetera, et cetera. It can be used as a golden master. So you can restore anything that you want to a known good state. Incremental changes can be done. And then golden masters can be ripped to next versions using source control like Git. You can treat it like code. Any current or previous versions can be managed in a programmatic way. The second benefit is around configuration management and verification. Since Ansible playbooks are the master configurations, there's no longer bottlenecks on actual humans around what the current, what you want to do with the endpoint that you're trying to manage. We're trying to get away from what we're calling artisanal networks, right? So things that are being done in traditional, custom, specific Snowflake ways. Maintaining those artisanal networks are really hard to maintain because, in essence, we're seeing a lot of people just doing crazy things like copying and pasting commands from Notepad to the command line. It's not sustainable. It's time-consuming. It's expensive. Lots of human failures there. So, we get a lot of customers, we ask, they say, do you know anything about your network? And we get ranges from, we kind of know, to we have no idea. So if you're utilizing Ansible and the AOS platform, you're going to have a more predictable and less scary situation in a production environment. The last thing is a proper configuration management implementation should provide anyone in the organization an accurate view of what each device's configuration status is at any time. We know that configuration drift happens. People are still going to log in via CLI to these commands. Multiple people, lots of people in enterprises have access to these networking devices. The change happens. We have to be able to verify the current configuration is still current and that no changes have been made. So we just want to make sure that authorized changes are made, they've been tested, and validated on a regular basis. If nothing needs to change, then the change isn't made, and you're good to go. I did want to talk a little bit about how change doesn't have to be all or nothing. Historically, traditional network operators and DevOps server administrators have siloed themselves from each other with a little common ground or integration, maybe other than a help desk ticketing system. That doesn't mean that either camp is right or wrong. Each organization must truly decide for themselves, what they need to be to become successful. In many cases, moving away from traditional network operations isn't possible. Similarly, a 100% DevOps strategy may not fit as well. The best strategy is the one that truly is right for your organization. We always try to say, do the most good with the least amount of change or effort. Automation is the natural solution here. It can make the most unpleasant, repetitive tasks perfect candidates for automation. Automation allows high-value resources to work on high-value work. I don't think any network engineer wants to add and remove VLANs all day. So leave those tasks to the computers and work on better things, right? The power of Ansible is the ability to commit changes, verify those, and then provide ongoing checks going forward. And before I hand it back over to Damien, this is kind of an architectural view of what we're looking at here. So, how does it actually work behind the scenes? So, for it here, you can manage network devices similar to managing them on the servers and compute devices. It doesn't show it here, but you have the ability, for purposes of this call, Ansible is actually talking to the AOS device, and then the AOS device is talking to the actual individual devices. So there's two different ways you can actually manage network devices. You can use Ansible itself directly, or you can use the intent-based model or the plug-and-play turnkey and utilize the AOS platform to manage the devices. So on network devices, the module, how it actually works in the back end is that the module actually sends the human CLI commands and then waits for standard output back from the network device to display back to the user via the playbook. There's nothing executed locally on the network device since there's no runtime environment. So modules, Ansible modules, are extremely important for network devices to be enabled with Ansible. With that, I'm going to hand it back over to Damien.
Thanks, Andrius. Thanks a lot. Actually, I think we did add a slide on what you were just talking about. Here you go.
Okay, that's what I was looking at. So yeah, this is. I was waiting for that one. You're right. So this is what I was trying to say was, there are two ways before. Yeah, the two ways to manage devices. Ansible can call devices directly, or AOS can do that for you. So it's extensible and very flexible. So for the purpose of this, Ansible is talking to AOS, and then AOS is talking to the devices.
Yes, absolutely. Depending on how high or low of the abstractions you want to work. So perfect. Actually, let me now talk in more details about this integration and works, because there's actually the modules that I'm going to talk, but we also have I think an interesting integration through the dynamic inventory, and I will that's actually we'll have a demo on that on how we can use that. So first, let's talk about the modules. So we do have developed a set of modules. I think we have a dozen or so today, and we'll keep adding more. But the idea is that as AOS lets you you can interact with the product either through the UI or through the APIs. For me, every time I work with the UI, I'm starting thinking, okay, how can I automate that? Because it's actually a manual action. So we have developed a set of plugins that will help you through all life cycles, the design phase, the deploy, and the operate phase, so that you won't have to use the UI during your workflow if you don't want to. you can really go back and forth between them, but then the modules, the AOS modules, will help you to completely and programmatically control AOS with Ansible. And here you can see you can create your rack type, your templates, your logical device. It's all those constructs that we are using to create this vendor agnostic solution. For the network resource, when you go in productions you want to deploy, you will have to create your IP pools, your SN pools. All of those can be automatically created through AOS, through Ansible to AOS. I think it's especially interesting, for example, if we take the IP pool, if you need to talk to your IPAM server, Ansible will be a great way so that you will be able to reserve the pool with Ansible, assuming your IPAM server, for example, is an Ansible module itself or has REST APIs enabled, and then you will be able to reserve the IP pool on one side and automatically create these pools on Ansible in a completely automated way. I really love this capability that Ansible is able to talk to all the components of your infrastructure, the servers, the applications, the networks, and create this homogeneous automation tool across all of them. And then we also have some modules that help you manage your network as it has been deployed and access all the live sets of your network. So it's actually done through what we name the AOS blueprint and param, and all those modules have really multiple functions. And if I have time, I will show you during the demo, but the goal is really that we build them in a very, and try to follow the Ansible best practices. So the modules are really based on the object, and they will let you create the object, delete the object, and access them and access all the information and the variables. So when we have, for example, the blueprint, you will use these modules to create, delete, access, manage, update any different actions that are supported by those modules. Also, all the modules support the check mode, and as much as possible, we try to make them idempotent, so that if you execute the same actions multiple times, you will have all the time a real feedback on what are the changes that have been made on the systems or not. All the documentation is on Ansible website. All the modules are part of the Ansible repository, and we would love to get feedback and contribution on them and collaborate with our customer on those. So now there's another way also where we see a great integrations between AOS and Ansible, and is when we will actually be able to use AOS as the source of inventory, and also has the source of a lot of the variables of the networks that we can feed into Ansible, so that you can create any ad hoc playbooks that you want, either using the modules that Ansible provide by default, or also if you want to create your own modules to talk to AOS or so on. But the idea is that AOS has a very deep understanding of the network. It has all the list of the device, it has all the states of the device. It has the information of all the variables and all the information that we are using to generate the configuration. So by using this dynamic inventory script, we'll be able to dynamically make all those informations available to Ansible. It's a very powerful function that Ansible is providing, and I've been always surprised to see that not so many people are know about it. Usually the advanced users are using it, but as newcomer into the automations, it's usually something that people are not looking at closely enough from my point of view. So actually, let's go to the demo. I think it's going to help everybody really understand that. I do have 3 demos, and based on the time, I hope I will be able to show you all of them. But the idea is really we'll start with the dynamic inventory, and I will show you how to get started, what are the kind of informations we can actually access. And then I will give you a real example of how you can, for example, collect show tag type of information on all your device across multiple vendors using Ansible and the AOS dynamic inventory. And the last one, if time permits, will be show you more about the modules and how they work. So let me switch to I didn't want to try the demo god today, so I actually have some video, and I will go through the video and talk to them. So let's go. So first, the dynamic inventory script is hosted on the Ansible GitHub repo, but it is not shipping with Ansible. So it means you actually have to go there inside the contrib/inventory, and there's a bunch of inventory, dynamic inventory already, including the Apstra one, and you will have to take this Python script and you need to install it yourself on your laptop or server. It does have some documentations on it to explain how it works, but basically the idea is that you will the easiest way will be to replace and place it into /etc/ansible/host, which is the default files Ansible will look at to build an inventory for the inventory files. And in my case, I just created a symbolic link between my Python file that you can see and the etc Ansible host. If you want to see, without running any playbooks, what type of information the system, you can actually run it in Python. And to be able to access to, you need to provide few inputs, and those inputs can be provided either in a configuration file, or you can use some environment variable. So here I'm just providing the IP address of the servers, and then that will let me run the file, and you just need to provide with the options --list. That's the Ansible way, and that will show you all the list of the device and the variables that you will provide as an inventory and as a source of variables to Ansible if you use this file. So all those informations are in JSON because that's the way. It's quite readable, and there's really two sections to these files. You first have the hosts list, and you see here we're using the serial number of the device as the unique identifier, the inventory host name in the Ansible terminology. And you see for each device we already have a lot of variables that are defined, like what are the states of the device, the IP addresses, the information about the architectures, really all the facts that the system will automatically collect from AOS for you. It will also have a lot of the facts that are coming from AOS itself about the status, like is the device operational, is it in maintenance mode, how is the communications with the agent, all of that. And then you will also have all the groups that will dynamically be created for you. And the groups will be based on the hardware of your device, will be based on the operating system, and those will be dynamically created. So here you can see for all the devices that are running Cumulus Linux, we'll have a group. All the devices running EOS, you will have a groups. All the devices running NXOS. And that really will let you build some playbooks that are really focused on the business, where you can say for all my EOS device, I want to use those actions and so on. Here I'm just gonna change one state and, for example, use EOS to define a device in maintenance mode, and show you that the status is automatically reflected on the system. So, and after that, I'll actually show you how we do have two modes in this dynamic inventory. The idea is that inside AOS, you can see the full list of devices as individual components, and this way we are actually defining them by their serial number. But once we actually take a device and we put it as part of the blueprint, each device will have its own name based more of the function it has on the network. Like now we will know that this device is actually a spine. It is actually, so the system is also able to work in this mode, and the way it works is you just need to provide the pod. The idea is that you can have multiple pod, and you can have multiple spine 1, for example, in those pods. So you define the name of the pod, and when you do that and you run the inventory, you will have very similar type of output, except that now we will have additional variables and information that are available. So in this case, because when we are in the pod, the device is actually configured, we will be able to collect information about all the interfaces, the IP addresses that have been assigned, all the information in the variable that we're using to generate the configuration. And we will also have additional groups like define on the role of the device. We will still have the groups based on the vendors and the operating system, but now we'll have groups based on, is my device a spine, is it a leaf, and so on. So it's really opened the door to, now you can leverage all those informations to build your own playbook. And that's what I'm going to show you right now. So let me escape from this one. So actually, to help really visualize, I've created this demo where I'm using Ansible to, I have a network that is composed of 5 devices. Some of them are Arista, Cisco, and Cumulus. And I want to collect a lot of information that I will need for to provide to my support in case that's the kind of operation that people are doing quite often. And that's actually very time consuming. So for me, that I see here a big opportunity for automation. And it's not easy to talk to so many different devices and so on. So what I have here is I have, for example, one playbook that is using all the different groups that we have. So you see here, I have first the sections that is based on the group name on the function. So for all my spine and my leaf, I want to do some local actions like set up my directory. And then for all my NXOS, I want to use the default Ansible module name NXOS command to execute some actions. And then I will want to copy back those files into my server using SSH. For Cumulus, I will use different modules because Cumulus supports different set of modules. And for Arista, I will use the AOS command modules. And now, if I run this playbook, I will automatically get all the IP addresses, all the information of the groups, all those informations will come from AOS. And I will be able to leverage that to collect my information using Ansible. It means I don't have to manage, and I don't have to manage my inventory. If I had a new spine, if I change something on my networks, even if at some point I decide that one of my leaf now used to be Cisco, and now I decided to replace that with a different Cisco model or even a different type of vendors, I don't have to change my playbook. Everything will be dynamically updated. So I think it's already quite useful and can save a lot of time, but I think we can go even further, and we can see here that all the information is on the device-specific link. So I do not collect the real ShowTech here because ShowTech are quite a lot of information. So I'm actually just collecting the list of interfaces, but it was really to highlight the idea and the process. So now collecting ShowTech is important, but I believe that, I know some of my customers, they actually believe that running ShowTech on some device is a disruptive operation. And while they do want to automate that, they're always afraid that someone will execute a ShowTech on a running device in production, that it might impact the traffic. And I always had this, I know a lot of people have this fear that automations can go out of control. So in this case, what I find really nice that now we can add the states of the device. Is the device in maintenance mode as a conditional before executing any actions in the playbook? So that I can have a very generic playbook, and I can have some safeguard and say, I will only execute these actions, the ShowTech, if my device, the administrative states of my device is in maintenance mode. And this information is coming from AOS because AOS has all those informations, and as the source of inventory for your network, AOS will be the place where you will define the states of a device. So for example, here you see that if I run that on my networks now, none of the tasks have actually been executed, and absolutely nothing has been done on the device because none of them were in maintenance mode. And now if I activate the maintenance mode on this leaf, and I run again my inventory, then automatically this set of only this device will be applied. So that's really provide all the power of Ansible to build some very advanced workflow, and tie that with the business and the integration to have some safeguard. Of course, you can manually populate those informations on the Ansible inventory yourself, but it will often lead to duplicate information and not easy to always maintain that. Having this integration, I believe, is very powerful. Now, we do have a lot of other information that you can use. This one was just an example. You could also, because we have all the facts of the device, one simple example would be that you will actually use, for example, what is the versions, the OS versions of the device that you want to use, and make sure that, say, if you have a lot of Cisco device, different generations of Cisco device, they're all running an XOS, but sometime over different major versions, you actually need to run different commands to get the same information. So you will be able to create some workflow where you will say, okay, I want to run this command on my device only if my operating system has specific versions or so on. So you could here, so I will put this device in maintenance mode because I want to use the Cisco one. And here I will say, okay, now I want to use the versions of the operating system, and I will only run this task if the major versions is equal to 7, for example. And if it's not equal to 7, I want to do something else, so that I will be able to create another task that will let you manage the variety of operating systems and vendor that you have on your networks. All those informations sometimes can be complicated to collect. I think we're close to the end. I probably won't. I think I'm going to stop here. And I'm sorry, but I won't be able to show the third demo. I think it's probably better to go and having the Q&A. Jeremy?
Yeah. Why don't we finish up with our closing slides, and then we can go to the Q&A. So if anybody has seen something they'd like more information on, or if you have any particular questions about either Apstra AOS or Ansible for networking, please do enter those into the question area, and we would be happy to answer those. So we'll be taking Q&A probably in the next couple of minutes.
Perfect. So yeah, so just remember, we are Apstra. We are providing the vendor agnostic self-operating networks. We do have a lot of project and code on GitHub, so you can actually find our Python library to control AOS, the same one that we are using to build the Ansible modules. Everything on www.github.com/Apstra. Our next webinar will be on May 24th. It will be about our upcoming major release, which is AOS 1.2. It will be named How to Operate the Data Center with from Fragile to Agile.
Oh, I like that. Fragile to Agile. I don't know. You need to trademark that. That's pretty good. So yeah, the last thing here on the Ansible side is here's some resources on our end. We just launched a new networking microsite, our homepage there, ansible.com/networking. We have a couple of videos that we have, some introductory videos, and then some other ones there. We will be creating an Apstra kind of homepage as well, and we'll be linking to this and other content as well. You can download Ansible 2.3 from releases.ansible.com/Ansible, or your favorite repo, yum, apt-get, pip, anything like that. Get an Ansible Tower trial, and feel free to join the community since Ansible is a community project. Join all the development lists in IRC and Slack. With that, I'll turn it back over to y'all.
I think you had one more slide on your upcoming Ansible Fest, yeah?
Oh yes. Oh yeah. Let's do that. I don't have control.
Can't forget Ansible Fest.
One here. Yeah, I gotta. Yeah, if you can advance that for me. I'm not able to from here.
Let me do that.
Yep.
Yeah, I think you're still sharing. Cool. Yeah. So with some events that Ansible's having, most recently soon, if you're going to Red Hat Summit in Boston in a week and a half, we will be there. I'll be there. The whole Ansible crew will be there. We're hosting a party the Monday night. So if you're interested in going, and you'll be in South Boston, we're hosting that before Red Hat Summit starts, and that's May 1st through the 4th, I believe. Ansible Fest is our Ansible-focused event. The next one's in London, and we'll have another one in San Francisco later this year. So if you're interested in getting anything Ansible in depth, you can sign up at Ansible Fest for that in London.
Yeah, those are great. I think I presented at the very first Ansible Fest when I was working at Juniper and doing the Junos module. So it's a great event, and it's a lot of fun. So definitely suggest going. I think this brings us to our Q&A part. So I've got a couple of questions that have come in. And the first one I think goes to Andrius. It's about support. Are the Apstra Ansible modules officially supported, or what does that mean?
The modules themselves, since they are, since Ansible, the open source project, is GPL v3, anything that's included must also be GPL v3. So the modules that have been included from Apstra are also open source. So as it stands, they are not supported. But I would say, and I'm going to venture a guess, that Apstra would, with a small fee, support those on your behalf, and with the solution that they have. So from Ansible, they are not, but we work very closely with Apstra, with maintaining code integrity and quality with the underlying Ansible infrastructure. So the answer is no from our side, but possibly yes from the Apstra side, if you all had any follow-up there.
Yeah, and that is, I think, your consistent policy with any third-party kind of contribution like what we're doing. Is that correct?
Correct. Yep.
Yeah, and we maintain essentially within the Apstra GitHub repo the proper fork and maintenance to ensure that we're contributing in the proper Ansible way, which is great. And then folks that give us suggestions and feedback, we're always on the lookout to make better and more modules as part of what the customer enablement team is all about. So thank you for answering that question. I got another question about how does the AOS agent interact with the devices? Damien, did you want to try to address that question?
Sure. So the AOS agent actually is using whatever interface the specific network device provides. So if we speak, for example, for Arista, we are using the eAPIs. If you are using Cisco, we are using the NXOS APIs over REST. If we're sitting on the box, we're also collecting some of the information, like on Linux, for example, directly on through the I forgot the name, the direct collection. But the agent is very flexible, and it will adapt to whatever programmatic interface is available.
Excellent, thank you. Yeah, so the Apstra software that runs on the device is basically running on top of whatever the network vendor provides. We're not replacing the operating system, even though we like to use the terminology of Apstra AOS as a distributed operating system for your entire network. We're fundamentally using what the networking vendor provides for us. And then from the AOS agent back to the server, we're using a binary optimized channel so that we get the efficiency of data collection and the runtime performance. So, so that's a little bit about our agent. And then the next question that I've got is, and I think you addressed it, but I think it's worth bearing repeating. Can my IPAM system feed network resources into AOS? So Damien, maybe you can just kind of go back through that use case, because it is a common one that again, people are asking about, how that would actually work.
Yes, so there's multiple ways to integrate. So we do have AOS provide some APIs to access all the, so we need to have some information about, for example, the IP, and we name that the IP pool as part of our resource management. And so we have all the APIs to access the information of what is AOS is using and what we're actually have been assigned to the device and so on. And you can create your own. So, for example, using Ansible, you can very easily create a workflow where you will reserve and talk to the IPAM system on one side, gather the information, and then talk to AOS automatically. We could also do some more in-depth integrations where through all the extensibility that we provide to build your own reference design, you do actually have the possibility to write some of your own Python logic, and through these logics you could also do some more in-depth integrations. But either way, there's a lot of way to connect with the rest of your management solutions and tools to manage your network.
Okay, thank you. Let's see, one final question with the time that we've got was, can I swap out one vendor for another within an AOS service, or what we call a blueprint? I'm just kind of adding here. They want to know, like, how do you do that with the product? And when you do, does that dynamic inventory mechanism you displayed automatically get updated?
So yeah, great question. So yes, we absolutely do have a way to. So as I mentioned, most of the product is actually very vendor agnostic. The way you define the design, the way you define all of it, and when you look at it, the part that is really vendor specific will be the configurations, how to push the configurations, and deploy. So this part is really as part of the agent. So in the product, you can actually very easily say, okay, I have a spine, for example, in Cisco, and I want to, I decided to go for a dual vendor strategy. So now I'd like to replace this device with the Arista, and you will be able to take it out of service and remove it from the network, keep all the information, and then later on say, okay, now I want to reprovision this device using another device that has the same number of ports and the same. All that matters is that we do provide the same features and the same. It has the same number of interfaces with the same number of speed. That's what is defined when you create your design. So yeah, it is very easy to do that. And to answer the second part of the questions, yes, as soon as you change that, all the information will be available through the dynamic inventory. The device will be automatically repositioned in the right groups and all of that. No specific action here. Everything will be completely dynamic.
Excellent. Well, thank you. I think that's all the time that we've had for today. I wanted to thank, again, everybody that attended and for your questions. And any question that we didn't get answered, we will respond via email or write up a blog post. In addition, please do check out the Apstra.com website and the Ansible.com website. Both Apstra and Ansible are, as Andrea said, really trying to pursue the expansion of network automation technologies, just, as a great thing that our industry needs. And so I hope you've learned a lot from this webinar. Please do rate the webinar. We love your feedback. Any improvements that we can make are greatly appreciated. So thank you again, and we look forward to hearing from you on our next webinar.